In the early days of the generative artificial intelligence boom, a quiet, almost unified consensus took hold among the industry leaders. The most capable neural networks were deemed too dangerous, too computationally expensive, and too complex to be let out of the research laboratory. Companies like OpenAI and Google built massive proprietary models, locking them behind strict paywalls and carefully monitored application programming interfaces. Developers and businesses could rent access, sending their text prompts into a digital black box and receiving a highly polished response, but the underlying architecture remained a closely guarded corporate secret. This was the era of the walled garden, a paradigm where a handful of heavily funded tech giants held the exclusive keys to the most transformative technology of the 21st century, dictating the pace of innovation and the rules of engagement for everyone else. The radical alternative to this closed ecosystem is open-source AI, a decentralized paradigm where the foundational building blocks of a computational model are made freely available to the public. In a proprietary system, you essentially buy a temporary ticket to a finished, unalterable product. In an open-source system, you are handed the blueprints, the algorithmic engine, and the raw digital materials. Developers can download the model weights, which are the billions of numerical parameters that define exactly how the artificial intelligence processes information and makes decisions. With those weights in hand, engineers can run the software natively on their own hardware. They can tear the code apart, inspect its internal biases, and systematically reshape it to fit highly specific, localized needs without ever asking for corporate permission or paying a recurring licensing fee. The strategic battle between these two opposing philosophies truly erupted in early 2023 with the unexpected release of Meta's Llama series. Initially, the social media giant intended the first iteration of Llama to be a strictly controlled, research-only tool available exclusively to vetted academics. However, within days of its announcement, the complete model weights leaked onto public internet forums. Instead of launching a futile legal crusade to scrub the files from the web, Meta executed a brilliant pivot. They fully embraced the unauthorized open distribution and eventually launched subsequent, far more powerful versions of Llama as officially open for commercial use. This single, highly calculated decision sent immediate shockwaves through the technology sector, proving that anyone with a capable computer could now access an AI model rivaling the proprietary systems that cost hundreds of millions of dollars to train. That initial chaotic release fundamentally accelerated the global democratization of artificial intelligence. An international community of independent researchers, scrappy startups, and coding hobbyists seized the Llama architecture, tweaking and refining it at a blistering, unprecedented pace. Within a matter of weeks, decentralized teams of developers were replicating complex features that had taken major corporations months to perfect behind closed doors. Startups suddenly realized they no longer had to rely entirely on Google or OpenAI to build intelligent applications. They could download a powerful free foundation, fine-tune it on their own proprietary datasets, and deploy it independently. This bypassed the restrictive API taxes that threatened to consume their profit margins, leveling the playing field for smaller innovators across the globe. Meta's sudden embrace of the open plains was not an act of technological charity or pure altruism. It was a fiercely aggressive business strategy designed to commoditize the very layer of the technology stack where its primary rivals were attempting to build an impenetrable monopoly. By giving away a world-class model for free, Meta severely disrupted the business models of companies whose entire revenue relied on selling basic access to AI. Furthermore, by establishing the Llama series as the default open-source standard, Meta ensured that the global developer community would effectively work for them for free. Thousands of independent engineers are now constantly crowdsourcing improvements, identifying security bugs, and building an entire ecosystem of software tools optimized specifically for Meta's underlying architecture. Despite this massive disruption, the tech giants guarding the walled gardens have not surrendered their dominant market position. Google and OpenAI maintain that the absolute bleeding edge of artificial intelligence requires centralized, proprietary development. Training the next generation of frontier models demands vast, interconnected clusters of specialized microchips and electricity equivalent to the daily consumption of small cities, requiring tens of billions of dollars in upfront capital. Proponents of the closed approach argue that this immense ongoing cost can only be recouped through proprietary licensing and enterprise subscriptions. They point to the established scaling laws of machine learning, suggesting that as models inevitably grow exponentially larger, the decentralized open-source community will simply lack the raw financial firepower and physical infrastructure to train frontier models from scratch. Beyond the stark financial realities, the proprietary argument leans heavily on the critical concepts of public safety and operational control. Advanced AI systems increasingly possess the latent ability to generate malicious software code, synthesize highly convincing political misinformation, or even provide detailed instructions for synthesizing biological weapons. When a model is locked securely behind an API, the company controlling it can monitor user outputs in real time, implement strict safety filters, and shut down bad actors instantly. Once an open-source model is downloaded to a private server, that centralized control vanishes completely. The original creator cannot recall the weights, issue a patch, or force a user to apply ethical guardrails, leaving the raw technology dangerously vulnerable to intentional, unmitigated misuse. The vocal advocates for open-source AI vigorously counter this safety narrative by championing the principle of security through transparency. They argue that a black box model is inherently more dangerous precisely because its internal biases, structural vulnerabilities, and catastrophic failure points are hidden from independent, third-party scrutiny. When the underlying code is open, a global army of academic researchers and cybersecurity experts can audit the system, identifying and patching critical security flaws far faster than an isolated internal corporate team ever could. This transparency also prevents a single profit-driven corporate entity from secretly dictating the moral alignment, cultural values, or political biases of a foundational technology that will soon mediate nearly all human interaction with digital information. This intense debate over control and transparency extends deeply into the enterprise sector, where data privacy is the absolute paramount concern. Multinational banks, global healthcare providers, and national defense contractors possess highly sensitive, regulated information that they cannot legally or strategically send to a third-party cloud server owned by OpenAI or Google. Open-source models solve this massive enterprise bottleneck through localized, on-premise deployment. A major hospital network can download an open model, train it specifically on millions of highly confidential patient records, and run the resulting intelligence entirely on internal air-gapped servers. The analytical power of the AI remains robust, but the proprietary data never leaves the physical building, ensuring total compliance with privacy regulations. The surging corporate demand for this kind of secure, localized AI has driven a massive industry shift towards smaller, highly efficient open-source models. While the proprietary giants remain locked in an arms race to build massive, all-knowing systems that require supercomputers to run, the open community has intensely focused on optimization. Through advanced mathematical techniques that compress neural networks without sacrificing their core reasoning capabilities, developers are now running surprisingly sophisticated AI directly on standard corporate laptops and consumer smartphones. This localized processing drastically reduces response latency, completely eliminates exorbitant cloud computing costs, and ensures that the technology can function seamlessly without a constant internet connection. As the strategic battle intensifies, the very definition of open source has become a highly contested, semantic battleground. Many models heavily marketed to the public as open are much more accurately described as open weights. In these instances, companies might release the final, fully trained neural network, but they deliberately withhold the massive datasets used for training, the exact algorithmic methodologies, and the original code used to build the system. This selective transparency allows corporations to reap the immense public relations benefits and developer goodwill of the open-source movement while retaining strict proprietary control over the foundational scientific breakthroughs, sparking fierce industry debate about what truly constitutes democratized technology. Regulators worldwide are now actively forced to navigate this fractured, rapidly evolving landscape. The European Union's landmark AI Act initially threatened to impose heavy universal compliance burdens on all foundation models, a move that could have instantly crushed the nascent open-source ecosystem. Following an intense, highly coordinated lobbying effort by tech companies and open-source advocates, lawmakers ultimately carved out specific protective exemptions for open-source developers. They recognized that legally holding a weekend coding hobbyist to the exact same stringent standard as a trillion-dollar corporation would fatally stifle grassroots innovation. Yet global governments remain deeply anxious about the rapid proliferation of unregulated, highly capable models across their borders. That urgent pursuit of localized control has sparked a global movement toward sovereign AI, fundamentally reshaping international geopolitics. Nations outside the traditional tech hubs of Silicon Valley are increasingly leveraging open-source foundations to build their own independent AI ecosystems. By utilizing freely available architectures like the Llama series, countries across Europe, the Middle East, and Asia can develop artificial intelligence that accurately reflects their own native languages, cultural nuances, and specific national security interests, rather than relying indefinitely on black box systems trained predominantly on Western data. The open plains have effectively become a powerful geopolitical tool, allowing emerging economies to bypass decades of foundational computer science research. The current trajectory of this strategic battle suggests that neither the walled garden nor the open plains will achieve total absolute victory over the other. Instead, the technology industry is rapidly moving toward a symbiotic, highly stratified ecosystem. The proprietary giants will almost certainly continue to dominate the absolute frontier, spending tens of billions of dollars to achieve the next major paradigm-shifting leaps in machine reasoning and autonomous capability. These massive closed systems will serve as the heavy artillery of the artificial intelligence world, utilized exclusively for the most complex, compute-intensive scientific and analytical tasks where sheer brute force scale is the only viable path forward. Simultaneously, the vast tier of models sitting just below that bleeding edge will become entirely commoditized by highly capable open-source alternatives. For the vast majority of daily business applications, automated customer service bots, and specialized corporate analytical tools, yesterday's frontier is more than sufficient. As open-source models rapidly and consistently close the performance gap with their proprietary counterparts, companies will naturally default to the free, highly customizable options for their standard daily operations. They will strategically reserve their expensive proprietary API calls for only the most demanding, high-value cognitive tasks, fundamentally altering the revenue projections of the major tech giants. Ultimately, this dual architecture ensures a much more resilient, competitive, and widely distributed technological future for humanity. The proprietary models will continue to aggressively push the boundaries of what machines can theoretically comprehend, while the open-source movement ensures that those incredible breakthroughs eventually trickle down to the broader global public. The ongoing tension between corporate profit and technological democratization, between closed safety and open innovation, is not a flaw in the development of artificial intelligence. It is the very engine driving it forward, ensuring that the most powerful technology in human history is continually tested, rigorously refined, and ultimately distributed across the entire globe.